Hi and welcome. The way we currently assign materials and like the actual build the node system in C-Ray for the materials is very limited. So we now have the new proper node-based material system that basically I just kind of grafted it on to the existing way we assign materials. I have this assign Bsdf function. Basically, this is doing the exact same thing we did before, just using the new system. So we just construct the different shaders here. We have a couple of parameters, roughness and color, and that's it. So the way it works is when we do let's do parse mesh. We parse the actual mesh, and then we already start getting all this kind of material information here, and then we actually parse the mesh. It's all kind of weird. If the mesh is valid, we'll start building the instances, and then somewhere, we start, doing this kind of thing, and then at the end, we actually assign the Bsdf to the material. This is not ideal. Basically, what it's doing, it's trying to read the wavefront material. Let's see. Like this one with these kind of material parameters, and then trying to use those in the Bsdf or the nodes. And that's not the way to go about this. Really, we need to specify these ourselves in the JSON. Ideally, we'd have like a proper shading language, which is what real programs do, but we don't have that yet. So we're just gonna hack it into this JSON. So I started sketching this out. So if I go to assign Bsdf, I can just kind of override all this stuff. So I figured that this is functionally like equivalent to this. So we'd have like color would actually be like an array, right? Red, green, blue. So it would read this array and then go like, okay, you have one root node, and then you have a diffuse here. That's how it gets the diffuse type, and then it's gonna populate it. It's gonna detect that, okay, the color is constant. If you have like a path there, then it would load up a texture or whatever you want. So there's a lot to figure out here. There's no right way to do this. So I'm just gonna try and build something that makes sense. There's not too many of these materials yet, so we just have like diffuse, mix, glass, metal, and plastic. Shouldn't be too hard to write like a recursive kind of parser for this. We're going to be using the JSON library that we have, CJSON, to do that. So we'll see if we can build something and then like test it out. So the way I would assume that, like, the way I'd imagine it to work is like a function that takes the JSON object and then returns a Bsdf node, and then it's gonna kind of be recursive. So if we just make another example here, like I'm just gonna put these one after the other. I don't think this is valid JSON, but whatever. So this array would be like in the object, I guess. Yeah, or like the mesh. And then if we have like type mix, then this would have parameters like what should we call this? A. And then A is just gonna be another shader basically. And this could be like, actually this is gonna be an object because this is just another shader, right? So this could be like type diffuse and then color, la. I'll do like, so this would be like there's a bunch of stuff to figure out with the parsing. So I have this function parse color. And right now it assumes that you provide like actual labels like R is equal to this, B, G, G, B, and A. But you could make it detect that it's an array. I think we have if JSON is array, right? So data, if it's an array, we could handle it differently. and then we could check the length. If the length is 1, then we could do like, oh, this is going to be a grayscale. I don't know how flexible we want to be about that, because then it's kind of ambiguous about like what you can and can't put in. The idea right now is to just like give really, really good error messages. So if you fuck it up, you can fix it. I mean, writing this JSON by hand is not ideal. It never was. Let me show you one of the scene files. Right now, I just write this by hand, but the idea with this is to eventually have like Blender write this out, and then, yeah. So it's not too bad if it's a bit verbose, but at least some shorthands would be nice. So we have a mix shader, and then right now it would complain that, hey, you don't have a second shader. It actually wouldn't fail. It would just basically detect that you only have one of them provided, the other one's null. Then it's just gonna basically return the shader that you did provide. That's not implemented yet, but that's actually a really cool thing we can do soon once it's implemented. So let me show you the mix constructor. So we have two constructors, new mix and new mix constant. The only difference is that new mix, you can I say interpolate. It's not interpolation, it's like a statistical pick and choose, but you can provide a texture based on which you choose between A and B, and then here we have just a constant mix. If we look at this one, this is how we construct them. So right now it just hash cons is a very recent addition. It's basically what it does is it will try and construct this node, and then it will check in a hash table if it already exists. That's why we have the hash and the compare. It will check that if it already exists, it's going to return a pointer to the existing one, so it doesn't allocate it again. But if it doesn't, then it's going to allocate it, put it in the hash table, and then return that. So yeah, it's just a big macro. But we can have logic in here, so it's like if either one of these is null, then just return the other one, right? Directly. Don't even do like a mix Bsdf, just return the other one, right? Something like that, but that's not implemented yet. We're not going to do it right now. We're just gonna kind of work on the actual parser. So let's try and do that. I'm delaying this. I'm kind of trying to think of how to do this, but there's one. What should we call this? Where should we put it? It's gonna go into the oops. Whoa. Where's this? It's in scene loader. Everything related to JSON parsing, like for the config files, is in scene loader at the moment. Obviously it should be split up, but let's just put this in here. This is gonna return Bsdf, and then parse node. We'll call it parse node. That's gonna take const JSON data, right? And the way I imagine it to work is kind of in a recursive way. So do I like this format? So here we have like b is equal to like, yeah, and this is gonna be type. I'm just gonna try and kind of get all the different types. So metal would have metal. We have a single constructor. It takes a color and a roughness texture, and again, these should be somewhat optional. Like we could have either defaults or just have it fail. I really don't know, but for this one we'd have like color again, and then in this case, instead of providing this array, we're gonna do like a file path to a texture. And this is where it really gets into the weeds. So if we do like input slash, shape, grid, plane, PNG, something like that, which is a valid path, it should be. No, it's grid.png, right? But normally this is provided in the actual wavefront file. So shape is grid plane dot matil. It well, it's relative to the matil file, but this is how it references that. So it's gonna be annoying to have to specify that. So we'll have to figure that out. But we'll come up with something. And for this, I'm not gonna specify roughness. It's just gonna basically set null there, and this will deal with that. If I think roughness is roughness, and then when it evaluates it, it'll actually check if you do have roughness. Actually, this one doesn't do that. That's funny. I actually, here it does that. So if it doesn't have a color, then it can't evaluate that. Then it will just get it from the actual material parameters. This should not be done this way. Ideally, you would always have these populated eventually. So the way we would do that, if you pass a null, then we're just going to set it to like black or something. Just have a default. That's what Blender does. And I've been looking at Blender lately, actually for inspiration. Let me open recent. So I've been just looking at this. Let me make sure this doesn't like, actually, let me disable something real quick because I'm actually doing some background processing. I'm mining cryptocurrency. I'm gonna stop that so it doesn't actually slow this down. So I'm gonna set this to GPU. Hopefully it doesn't mess up the FPS on there. Right. So this is what I've been kind of looking at for inspiration. I've just been kind of looking at this node graph in Blender, as how Cycles in Blender does materials. It's really clever. I've been using it for a while. A couple of years, and I always kind of wondered how this was implemented. So now I'm kind of finally getting close to it, to being able to like implement it myself. So the way Blender does it, if you have like, let's say one of these is not connected, it's gonna go black. So I guess we could just have like a default, diffuse all black material that we set as a failsafe, or something obnoxious. Like the way it works now is if you don't have any material like valid material type specified, it'll just set this all to warning Bsdf. Let me show you what that looks like. It's a bit funny. Oops. Whoa, really not in the typing mood today. You can just render whatever this just overrides it for all of them. Linking. There we go. Oh, this is actually a pretty heavy scene. It's gonna, yeah, it's like an obnoxious kind of pink and gray, something went wrong, notice me kind of material. It's actually kind of cool looking with this scene. But, yeah, let's get back to parse node. How should we do this? So I'm just gonna use this as sort of a model, kind of scratch pad for how I want to structure it. This whole arrays thing, I don't know about that. I don't think we're always gonna look at the type, so I don't think we need like the array thing. How do there was a way to re-indent stuff in Vim and I completely forget. I'm googling it off the screen because you select it and then you do what? You select it and then you do what? GG. You select everything and then GG? Well, apparently not. Okay. Well, whatever. This Vim tips fandom is not very good. GG. Oh, okay. GG to the first of the file and then G. Okay. Cool. GG equals capital G. Okay. It actually re-indented this wrong, but whatever. We don't have to care about that. So, this is gonna have a comma in here. I'm gonna at least try and make this valid JSON. Sorry if I'm a bit rambling. I'm just kind of figuring this out still. So we have a mix, and yeah, I think that makes sense. So each Bsdf would have like, like mesh would have input HDR. So this one right now, it has like, plastic and roughness. These are kind of just stuck in here temporarily. But what you would actually have is like, the Bsdf, or like material is, and then it'll be here, right? So something like that. So let's figure this out. Okay, so I'm gonna have to refresh myself on how to use CJSON. I haven't written like new parsing code in a while, so we're just gonna have to figure this out. So type get object item data type, and then I'm just gonna assume for now that we have that. Does this return null if it doesn't find that? It does. And because if we don't have the type, then there's basically nothing we can do. And then let me think about this. So the obvious thing, you can't. Yeah, I'm just gonna do like an if else kind of thing here. So this is gonna be a type value string. Also, we're gonna want to assert JSON is string type, right? And then let's just go for like one at a time. Let's start with diffuse. And then we're going to get the color. There's a lot of like sort of boilerplate stuff that we're gonna have to do for like defaults and handling errors and stuff. We're just gonna kind of bang this out and see if we can get it working. So color. I don't actually like this to be called data. Let me do like node. Yeah, so there we go. So like the current node basically. And then we're just gonna assume that there's a color again. Should we just throw like assertions here? We'll do that. For now, we'll replace these assertions with proper error handling later. But for now, we just want to know that it's invalid. So, and then the return new diffuse, and we're gonna have to. I got a new mouse just today. It's the Logitech MX Master 3. It's got this heavy scroll wheel that like just flies when you flick it, and I really kind of like it. So include. Let's see. Node share Bsdf. I think this will become pretty good. So the way we allocate these nodes is you have to pass in the world, and it sounds kind of bad that we have to do that because right now it contains almost everything. It doesn't contain the render state, but it has all the stuff. But it'll allocate it on it'll use the hash table and the memory pool that the world has. And eventually all of this stuff will go away and we'll only have the hash table and the memory pool. But that's not complete yet. So that's why we pass it in. So we're actually going to have to do like no, it's world. W. Right, and then it's going to have, if it is a color, now we're gonna have to figure out, let me think about this. Let's just hack it. So we're gonna do like new constant texture W, and then parse color, and then color, like that. So, but we'd have to handle the actual case where we have like a path or a array or stuff. Actually, parse color can handle that for us, but then we'd also have to know if it's actually a color or a path. That's what we're gonna have to handle here. But that's fine. Okay, I guess that kind of works. Else, if I'm just gonna do it this way right now, string equals type value string, and it's gonna be, let's do metal, and then this is gonna have so that's gonna be a bit repeating, but if you know of a better way to structure this, do let me know. Get the object for node. So color, we're basically gonna repeat this. So okay, and then it's gonna go like const roughness. So metal material. This is all still in flux, but right now a metal material has a color and a roughness. Let's look at what Blender does. Blender actually has the same, so it has glossy is effectively metal basically. So it has the color and the roughness. You can adjust all the stuff in real time in Blender, which is kind of nice. It also has this normal, and I'm not sure what that is all about just yet. Let's plug it into something weird. Yeah, let's not do that. I don't know what that is for this in this context. I guess it's the surface normal, so you can have like a bump map or something. But yeah, color and roughness actually matches fairly well to what Blender has. Blender has all these different modes. We just have the one that kind of works. That's fine. Let's just get this over with. So no roughness. Then return new metal. That's gonna be like W, and then we'll deal with the textures later. Constant texture W and color. Oh, parse color, color. Then new constant texture W plus color roughness. Something like that. This is very dense kind of code. Let's figure out what do we have. So we'll do glass. New glass. Now we'll kind of have this here as our template. This also has color and roughness. Really, it should also have an IOR. So if we look in Blender, I think it would have an IOR. Let's see. Shader. Glass Bsdf. Do we have one? Refraction Bsdf. Is that the one? I thought they had. No, glass. There we go. See if we can stuff this in here. Let me put this up here. Do like glass for that one. Disconnect this. The shader output. Put this in here. Shader. There we go. We got glass. And then the color comes from here. So yeah, so glass should have an IOR value. It does not have that just yet, but we have to add that. I'm gonna do a to-do actually. Input. So right now, the way glass works, it just gets the IOR from the actual material itself. And again, this is not what we want. We have to pass everything in the constructor and have it in the node instead of like this. But again, to do, we'll figure it out. So we can copy code, I think. Color, and then roughness as well. Make this a bit faster. Yeah, pretty much the same thing here. Right. gotta use semicolons, man. And then if we don't have anything, like we can find that, then we're gonna basically throw up a warning. Warning. I can't figure out this. Well, that's not I can't figure out this node. And then we'll just return warning Bsdf. Do we have the warning? Where is that? It's in assign. It's in material.c. I kind of want this moved. Elsewhere, let's do bsdf.c, I guess. You can put this in here. Still getting used to this mouse. The sensitivity is a bit weird. Oops. Right. Don't really care about that. Cool. Okay, I guess this is coming along pretty nicely, at least for like a first draft. I'm sure I'm gonna rebuild this many times. So if we have, let me bring back the list here. I usually like to have this file list open. Plastic. Type value string plastic. Oops, that's not what we want. What does that have? Return new plastic. It's just gonna have like world and the color. Again, we're gonna just do it this way. No. New constant texture. W parse color. Cool. Now the really cool part comes in. This is how we're gonna do this kind of recursively. So I do wonder if this unused function thing will go away if we actually call it recursively. It shouldn't, right? If we don't call it elsewhere, that shouldn't go away, but I'm gonna bet that Xcode is not gonna realize that. String equals type value string, and we're gonna do mix. And this is cool. So return new mix, and then this is going to look something like this. So see JSON get objects from node A, and let me think here. This one. So mix is gonna look like this. A and B. I don't know if it makes sense to call them A and B. What does Blender? It just calls them both shader, and then the factor for the how you mix them. So in this case, in Blender, if you didn't see this, we're just generating a checker texture. We just plug this into the surface. It's not gonna work. We plug this into like glossy and then do that. That's gonna work. But we do like Shift A. Let's do like a diffuse. Just stick this in here. It's like a black and white checker texture. And we're basically kind of modulating between these two shaders using that. It's really cool, I think. Because normally, what you can do with this factor is basically now it's all this red material and then just float going up and up and up. Now it's a mixture of like 24% red and then rest blue. Actually, it looks really cool. Let me set the sample count. Welcome to this episode where instead of developing C-Ray, we're gonna just mess around with Blender because it's really cool. So this now, it's on my GPU, so it shouldn't be slow. Let's do more samples. There you go. Cool. Even more because it's so fast. Let's do 128. So there's that mixture. Let's go more. See, it becomes more blue. But then instead of having this one value for the whole thing, we can just plop this in here. And actually, that's not right. We gotta plug this into the factor node. There we go. Right. So we can already do this in C-Ray, but oops, we can do this in C-Ray, but we have to code it inside the engine. We can't configure it. So trying to do that now. Let's get back to this. So node A, same thing for B. Right, and then we're gonna actually parse them. What should we call these? JSON A and JSON B, because I actually what happens if we call new mix? It returns the struct Bsdf. These should return a can we return a const? We can. I guess I just didn't realize that we can return a const from here. We're not gonna do that now. I'm gonna add that off the video, but yeah, I'm gonna make these all const. Because when you pass these in, they're not const. They should be const. All of this should be const, I think. Does that make sense? New mix. Yeah, if you make a diffuse, I don't know why these aren't const. They should all be const. Yeah, we'll deal with that off the video, but yeah. Yeah, so right now they're not going to be const, but A is going to be parse node world, and then JSON A, then struct Bsdf B is parse node W. This is really cool. JSON B. Will the error go away? It did. Now it's like, oh, well, you're calling this function, then that means it's not unused anymore, even though there's no way we can get into this path. But anyway. A, B, oops, B, and then the lerp. I guess we need that as well. I'll call this factor starting from now. I'm gonna have to change all that stuff. Factor starting right now. Then this is gonna be, again, we're just gonna do a constant. Texture W parse color factor. Cool. Oops. Don't do that. Oops. So now we don't, actually, it did realize that. It just didn't warn us when there are errors in the code. Cool. So it's not that dumb. This is a really old version of Xcode, like a couple of years old, because I think I've mentioned it before. This is a Hackintosh, and I just haven't bothered to update it since like 2017. It's a huge hassle. So I'm running like, which version is this? It's like 10.12. It's really old. What do we have here? Yeah, Darwin 16.7 from 2018, January. Yeah, that's not ideal, but it works. So cool. Now we have all those. We have plastic, metal, glass, mix, and diffuse. So all those are handled. Now we want to let's make the parse node function also parse texture nodes. We're not gonna split this up just yet because it's not too big. So we're actually gonna use this for parsing the texture nodes as well. Because these all return, actually these return texture nodes. Yeah, we'll make a new function. Scratch that. Set take struct texture node. Same kind of deal. And then this is we're gonna pass in. We're just gonna pass in the factor, right? this is gonna be like parse texture node W and then factor, something like that. Same for this one, new constant texture. New constant texture, color. Yeah, we're figuring this out as we go. I think it's working out. Same deal here. Right, do we have anything else? Okay. And then I actually was thinking about this like all of yesterday, just like how I want to do this. There's so many different ways we could go about this that I just kind of got stuck. So I guess we're making progress now. I kind of like it so far, but we'll see how it turns out. Let's do this as well. So if it's like we can't figure out the node at all, we're gonna make a texture node that's like all black. So we're just gonna do like texture node. We'll do like unknown texture node. Yeah. We'll do a similar deal to like the warning material. Yeah. New constant texture. Oh, it's gonna need the world, isn't it? Yeah. Still getting used to this acceleration on this mouse. There we go. W and then black color. Just all black. And diffuse, so it's basically gonna absorb the ray. It's not even gonna bounce off that. Because in path trace here, we actually look at the color of the material we hit and take a probability of that, of like, does it make sense to continue bouncing off this? And it's like, if it's like Vanta black, which if it's all like black, there's no reason to bounce off it to go further. You're never gonna recover from that. It's gonna basically, in physical world terms, it's gonna absorb all the energy that goes on it, which is impossible in the real world. Stuff like Vanta black is close to it, but it's still like 99.999 something. So this is not obviously not physically possible, but since it's a render, we can do whatever you want. So there we go, unknown texture node, right? So if we don't figure it out, unknown texture node W. Type, and actually we don't have a type, do we? So I think we're gonna have to deduce this. If CJSON is string, then it's gonna be a texture. We're gonna assume that it's a path to a texture. Let's see. So node, yes. Then path to a texture. New image texture W. Then we're gonna, now this is where it gets weird in terms of like currently all the textures for material are owned by the material. So, whoa, what? There we go. So they're in here. And then all the Bsdf stuff is new that I just wrote. So all this is using the memory pool. All this is like still, you know, destroy material has the freeze for all this stuff. What I'm gonna do now is just ignore that and leak memory. But that's fine for now. We're gonna throw all this on the memory pool anyway. Does it actually do that? Doesn't. It takes the texture and just sets it. So this will get leaked right now, but that's fine. Load texture from node value string. No options for this, although we could parse options. We could do like if this has, let me think. So the color is going to be like that. So if CJSON is object, if it's an object that contains more stuff, then we could put stuff like on node. It'll have more params in here. So in this case, it would look something like this. So instead of color like this, it would look like, I'm just gonna do another color. Color is equal to like this, and then we'd have like stuff like the options that we have for load texture are like wait, it's in the texture node actually. Options, is it used? Yeah, if we want like transform false, so this would be like don't do the sRGB transform. So I'm just gonna kind of sketch this out. Node transform. We want to do sRGB transform. And then assert CJSON is bool. And then we'll set to 0, and then if is true. Actually, I think we can just get this, the value boolean. Oh. Interesting, it just used the item type, but there's no like value. Yeah, it has string int and double, but it doesn't store the boolean here, which makes sense, I guess. So if CJSON is true, then options I guess this means you do want it, right? Is this actually the right? I don't think I've ever used this, like bitwise and is equal. I assume it means that options is equal to options, you know, bitwise and sRGB transform like that. Saying the bit fail, but I assume that works. I've never actually done that before. We'll see if it works. More debugging for later, I guess. I just realized I'm wearing my headphones. I don't need to do that. Okay. So, I sound completely different right now. It's weird. I was like blocking my ears. Anyway. Yeah, that makes sense. So we would have like that. But otherwise, if it's just a direct string, like we could do like car is equal to like just a path. Well, actually we have that, right? We have it here. So it's going to be a path, right? This is going to be a big old else if thing, but that's fine for now. If it's an object, we do that. If it's a string, then we do that. Otherwise, we're going to assume it's a color. Return. That will be a constant texture. Constant texture, W, parse color, node. something like that. And then we're gonna have to actually improve the sparse color logic so we can have all this different kind of stuff, because right now it wants you to do something like this. Do we have any examples of that? Yeah, we do. So it wants this, but this is kind of really verbose. Like, oh, really? You need all that stuff? So we're gonna work on parse color. Arrays. What else will we have? We're not gonna have like the path handling here. It's just gonna accept an array as well. Yeah, we already did the to do. Yeah, I should read the code. Okay. So path to a texture, value string, and then options. Right? Cool. Actually, options is gonna be 0 here. So this is gonna assume it doesn't have options, and then this is gonna do new image. Then it's gonna do like if we have options in there, we can basically assume it's gonna be an image texture, right? Again, there's a million ways to do this. So if we have this one transform false, then what do we call the path? So here it's like just the object, but here it's gonna be path, I guess. Right? I guess we'll figure something out. So let's see. Path as JSON. I just want it to be consistent, and that doesn't feel consistent, but whatever. Object node and then path. Path and then return u image texture w load texture path string options, something like that. It's rough clay. We can work with it. Path texture. We don't need this comment. That's obvious. More like no options provided. Go with the defaults. Yeah, I like that. I think that's pretty good. Let's see. Unknown texture node, and then here it's already hooked up. Should we try this? Let's try it for like, we're gonna do it in a way that kind of makes sense. Let me, oops. Do we have stuff changed? Yep. Okay, so, let me make this a bit bigger. Make this one go away for now. A little bit bigger. Can you see this? I guess the text is big. So, I don't want to break everything right now. So the way I'm gonna do it is I'm gonna override it if it's provided. So if we have the material node in here, then we're just gonna override everything. And this parse mesh functions is a mess. Do we want to refactor this now? We kind of do, don't we? Jeez, what is this? I didn't refactor this when I did the new wavefront loader. I should have. I'm regretting that now. Oh no. Oh no. This is all like basically I just wanted to do a feature quickly. I just added it into this function, the configuration option. So it's like, yeah, clearly I wanted to make meshes emit light because I just added this like, oh, if it's an emission and we do have an intensity, then just kind of patch in the intensity with this line here and directly into the material. This is not the way to do it, clearly. Oh, for glass, we do want to provide the IOR. That's a good point. So because right now we don't have the actual IOR. provided, but we do still want that. Even though it's not provided to the shader, we're just gonna hack this. Don't do it like this. If you don't provide the IOR, I think it's gonna default to like 0, and that just makes the glass look weird. Get object node IR, and then assert is, I guess, number, right? And then value double, and then geez, we don't actually have the, yeah, we're gonna have to fix this because we don't have access to the material. Can we do like last? Yeah, we can't. Okay, we can't patch this in here actually because it's written correctly. Yeah, I just noticed that. Yeah, we're not gonna do it like this because we can't. So glass is not gonna work for a bit unless we provide it in here. But how would we do this? So let me like this parse mesh. We start with getting the Bsdf. Maybe we should just rewrite this like completely. This is horrible. Like, what is this? This was from I was just quickly testing all the. I wrote a new wavefront loader, which was a bit faster than the old one, and then I just stuck it in here. It's always like parse mesh and then load mesh, and then load mesh calls load mesh new calls load mesh, and then load mesh calls parse wavefront. It's all a bit you know, kind of on its way. It works kind of. I want to destroy this function. I want to burn it to the ground because I don't like it. God. Yeah. How we do this? I'm just gonna write a new one that because now we want to have the existing stuff working. Right. So where do we actually set the material? So we set the type here. Then we use it in here. So okay, we can just replace if we have the mesh or the material provided. We'll do that. Otherwise, we're gonna do this, whatever this thing is. Right. Yeah, that's how we're gonna do it. But then this we want to keep. This is what we want to skip. This down here. Right. So const c JSON material is object data material if material do this, else we're gonna do this, something like this. I just kind of temporarily want to override it only because I don't want the whole scene to break. So this should still work, right? Do like 100 samples. Wait, what? Okay, yeah, there we go. Oh, okay, well that was expected. Where did it crash? Well, okay, it got to rendering, and then this crashed and render thread. That's fine. Do debug build so we can actually get the symbols out. Do you see how quickly it just linked? Ever since we had the IPO, we don't have investors yet into procedural optimization is what I mean. It's been really slow to link. So there you go. That's more like it. What do we see? I could just open this in the debugger. I just want to check this. Yeah, whatever. Don't send. Let's run this in here. Should work. Do like HGR. We'll add like just 10 samples. We don't care about that. None of that. And yes, you can emit the oh well, there we go. Okay. So the sample function. Oh. Okay, so material. Okay, the material is null. That's kind of weird. I don't know how it already broke that. I didn't change much, did I? Oh, right. I already put this in here, didn't I? Right. Now it should work. Right. So we don't set materials, it's not gonna work. There we go. Cool. Let's actually put something cool in here. We're gonna do, for the Venus statue, we're gonna do, and now I have to actually remember what I did. So type, it's gonna be mix. We'll see if this works first time. We'll see. We don't have to see. So A is gonna be type diffuse. Color is gonna be, geez, I haven't fixed the thing yet, so it's gonna be verbose. Right, and then B is gonna be type. It's gonna be plastic, and then the color is gonna be again. You can see why I want to do the array thing. There we go. Okay, and then the now I'm gonna have to factor. Is it just color? It should be a color, right? So the factor parse texture node. Yeah. Cool. So it's just gonna be a color. Okay. Oops. We'll do 50. Actually, we don't have the checkerboard in here, but we can patch it in, right? So if we have like, I don't know how I'm gonna want to do this. I guess it's gonna be like an object, and then let me think. Oh, by the way, this is not gonna work. It's gonna see that it's an object, and then it's gonna try and parse it as this. Right. Okay, we're gonna have to figure that one out. How would we? Well, I don't think it was gonna work anyway. Let's just let's do a simple bright red diffuse, just something like that. Yeah. Diffuse, and then we'll just set this to empty and just turn new constant just to get this to work. W red color. Cool. And then parse node. I have to wire this up. So Venus scale should be a red diffuse material once this works, if it works. So if we have material, this also kind of assumes that we're not gonna use the material properties at all, and I don't think diffuse uses that. because I showed earlier that glass material, for instance, gets the IR from the material, and that's not going to work with this. So this will we'll have this, so it'll evaluate this correctly. Yeah, diffuse should work, I think. Yeah. Let's do diffuse. Let's see if that works. Just to get something working. So node is parse node w. That's gonna be scene, and then material, and then it's just gonna set the Bsdf for all of them. And this is horrible, but we'll do it this way for now. For each of the materials. Node. I think that should do it. We don't care about any of those parameters. We don't call it sign Bsdf. Maybe that'll work. We'll see. This is like the simplest case you could have. Let me do like not 250 samples or 10 samples. Just for testing. It's all black, so it couldn't figure out the is there a warning? No, invalid Bsdf while parsing mesh. Okay. It should probably dump the JSON, maybe. No, where does that come out of? Invalid Bsdf while parsing mesh. Actually, didn't write it here. Oh, right. It's up here. Yeah, warning. So it doesn't care about that. That doesn't matter. Load up the mesh. Parse the instances. And then I'll try and get that off. This one, it should work. I'm gonna fire up the debugger. Yeah, it does get here. Okay, cool. And then it should be of type diffuse. Yeah, sample diffuse. It's correct. And then it's gonna set that to just mesh or material count. There's only one material, of course, so it sets the Bsdf. Why would that not? Oh wait, hold on. No, when we're path tracing, we're just gonna evaluate the sample function. Sample.color. Okay, so why would that return black? It should return red. Something's fishy here. Let's see, parse node. Then whenever it parses, it gets to diffuse. It's gonna get the color, right? Color. It's gonna shove it in here. Yeah, get the thing. And then new constant texture parse color. Oh, this uses the old one. Okay, yeah. Parse texture node. Yeah. Okay, I just kind of missed that before. Should work now, maybe. Look at that, it actually works. We managed to build something on this video. That's good. Nice bright red. The reason why it's black in the reflection in the green sphere is because it actually models it. So once the light ray coming from the camera hits the green sphere, everything but the green is gone at that point. So if you try and add red later, it's not gonna do anything. It actually does that in real life as well. So basically, the green sphere absorbs all other wavelengths besides green. Wait, yeah. So this red light coming off this statue, in real life it would go the other way, so the red light coming off the statue is absorbed by this green metal surface. So none of it reaches the camera. And since there's no green in the statue, it shows up like all black here. It's not a bug. But that works, okay. We have a sort of an inkling as to how this could work. It's going to require a lot of work. We've been live for an hour. Let's do a bit more of this, so we can actually kind of make this work. So to make this fully integrate, we're going to have to do a lot of refactoring of the actual nodes themselves as well, because when I was building them, I just kind of wanted to get them working. So I'm almost tempted to commit this, because we're on a branch. I can commit incomplete stuff to like just have a base to work off of, like a clean slate. Yeah, let's do that. Even if it's broken, it's still fine to yeah. This is gonna require work. Let's just commit whatever we have. Let's see. So I forget how this is used. So I guess patch, and then we're gonna do 4. I forget how this works. Oh, right. Hit return. Yes. Patch. I'm still getting used to this tool. Yeah. Is there a way to do them all? Can I do like 4, 5, 6, 7, 8? No. Okay, 4. I'm sure you can get real fast at this. Yeah. 4. Yeah. Patch. I think I'm using this wrong. Texture node. Sure. 4. 4. Yeah, stage that hunk. Stage that. Yeah. We'll throw all this in there. Do we have anything in here? Nah. Okay, I guess I'm happy with that. Okay. Quit. Did that work? I think that worked. Start working on the new node parser. So I guess that's good. Push that up. Whoa. Okay. So, what should we do first? Let's fix up parse color first. Let's make it handle arrays. Parse color. Because that's something I've been wanting to do for a while. How will we handle this? Let's see, JSON get array item data index 0. And what if it's not there? It's gonna return null. Okay. Okay, I guess we can do like so. New color dot red is gonna be cjson get item data 0. If it is there, then it's gonna be cjson get get num wait data 0 value double. This is not very good. Oh, otherwise we're gonna set that to 0. Yeah, this kind of just assumes there are gonna be doubles, like numbers. We'll do it this way for now. Oops. And yes, they are typed out all the way in my structure. So 0, 1, 2, 3. This assumes the order, of course. But that's fine. Something like that. Oops. Okay. Right. So, parse texture node. Let me think about the logic here. So, first of all, let's try this out. We will do it with one of the spheres. What do we have? One that's real good. We have metal spheres, glass. Yeah, we'll have the blue glass sphere. Right, so this glass sphere, you can tell because it's a sphere, it's glass, and it's got a lot of blue in it. So this is gonna be 0.1, 0.1, 1.0. Like this. Like that. That should work now. Maybe? Oh no, it won't. It will mess up because we're not using... Wait, it should work. Color. Parse color. Whoa, this code is like just disgusting. Okay. A lot of hacks, basically just a collection of hacks. So yeah, if we get the color, it's not null. If it's a mission, otherwise, diffuse parse color. Right? Do we ever get here? Right? Red. Oh, wait, what? Right, but new color. Yeah, it does get there. Cool. Blue. So why did it not work? Oh, and then we want to return it here. Yeah. Because otherwise it would have just gone past this and tried to find these, and it didn't occur. Yeah, of course, that makes sense. And there, the IOR or the color is like all kinds of messed up. What's in here actually? How did that happen? How's parse sphere? So it gets the right, and then instances, okay. Jeez, this code is just something. Why would that? Alpha's 1. What? First of all, that's all wrong. Oh wait, yeah, we of course, yeah. We're not really caring about that. Alpha 0. Ooh, right. The alpha should default to 1, and the reason why it went transparent, and that's different from the glass transparency. Alpha is different. Why did it not render? Oh, I aborted it. So we defaulted to 0, which basically makes the object completely transparent. But the alpha transparency is a bit buggy. You can still sort of see a ghost sphere, but this should default to 1 if it's not available. Still minor semantic difference. Recompile that. Should work. That works. Cool. So we can commit that. Do we want to commit that? Yeah. Girlfriend's playing with the dog. I don't want to commit it like this. Do I? Because right now it assumes. We can check. We can check, like, make sure that it's a number, and then get that. Is number C JSON data 0, something like that. Because then it'll just default to 0 or whatever. If it's not a number, I like that better. What does that check actually do? It's a bit unwieldy, these lines, but this number checks that it's not null, and then it checks the type. Evidently, FF is a number. Cool. Right. All these use. Oh, right. It's a bitwise add. Right. So it checks if it's this. Right. Cool. That's good, I think. We'll put this right up front, though. And here we'll do like assert JSON is object data, like that. And we should really be using debug builds. For like testing, because assertions don't get fired when the Andreas boundary error. What happened there? What did I break? Oh, right. It's trying to get it off the end of the array. Why did this not happen before? Oh, get array item 0. 1, 2, 3. It's gonna return null, so then it's not gonna be a number, and then it's not gonna do that. Right. I did break it. Cool. I like that. Let's commit that. Patch, single loader. Yep. Oh yeah, we removed that. What? Oh. Cached stage differences. Yeah. I might actually get rid of this whole, RGBA thing. It's useful because we can have stuff like Kelvin. So this just gets the Kelvin degrees, and then it'll use this function to convert that into a color value. I did not come up with this code. It's from this place, Tanner Helland. But yeah, the RGBA thing is kind of super verbose. I don't know. I really like kind of strongly type out. Of course, JSON's not type, but like writing out the name. But I don't know if I like it anymore. So that's good. We now have a working parse color. Let's go back to parse texture node and fix this. So let's not first of all return red color always. And then let's look at our file. So a color can be an array, in which case it's guaranteed to be because now there's a conflict here, because if it's an object, it's either, yeah, we can just handle it. We can just like look for a it's hacky the way it's gonna be. But if C JSON is array node, it's guaranteed to be a color. Well, that's already handled by the int case there, isn't it? So good 1, 2. So just check if it got R in there. And then parse color uses case insensitive, right? Get object item. Is there like a, yeah, it's case sensitive, but by default it's not, right? So kind of like that. We'll fix that later. Otherwise, we just have more parameters in here, like yeah, sRGB transform. We could also have like if we want to have texture interpolation, we have bilinear interpolation for textures. It's really hard to see, but like, yeah, it just smooths out, but we can disable that. And then when we make a new image texture in the options, I don't think it's actually eval texture. Right now it just checks for sRGB transform. So we're not going to put this in here yet. We'll do that later. But if we do have sRGB transform, then we're going to set that. Otherwise, it's going to be 0. And then the path will be that one. Then we just return the image texture. Otherwise, you can just, this is a shorthand. Shortcuts or whatever. Okay. This should kind of work, I guess. Maybe. If we can get this kind of working, then we can stop for tonight. So this color, we're just gonna set this to like gray or something. Right, so diffuse, and there. Will it work? That's the question. Look at that, it worked. Let's make it blue. Oops. Make it like really blue. Oops. Crap. Do a release build. Feeling dangerous. I think this is a good base to start off of. This video is getting a bit long, so I'm gonna end it here. But I'm gonna build on this obviously after this recording. Not now though, because it's 1 AM, but you know, tomorrow. That works. So we can, once this is completed, we can actually start working on these nodes properly. That's really cool. Let's commit this. Patch 4. Yes. Okay, that's all we did. Okay. Do we do not have anything else? No. Okay. So lots to do, but I'm running out of time right now. I gotta go to sleep. So if you got this far, thank you very much for watching. And it was kind of boilerplate parser writing. I was debating if I wanted to record it or not, because it's kind of boring, but at least you got to see kind of how the nodes are built now. Instead of just having an array of functions we can choose from, we can actually mix and match and combine them. And the way you know, we construct them is they're all allocated on the node pool, the shared memory pool, which I think is really cool. It was not my idea, but yeah, cool. So if you got this far, thank you very much for watching, and good night.